So let's let W equal x minus a divided by b, like this.
Squared.
Oh, this is squared, right? Like that? Oh, you can't see it. There you go.
You don't want W to equal to the square.
You don't want W to equal to square. Okay.
But you want it to be x minus a over square root of b.
Over the square root of b?
Yeah.
The whole thing squared.
Oh, this like this? Oh, I see what you're saying. Okay, I understand. Cool. So that's when you substitute it in. Nice. So we do dw. Should we do that? Okay. So what's dw going to be? What is it going to be? Isn't it dx over? Yeah. So 1 over root b dx like this. Is that correct? Okay. So dx is equal to square root of b dw, like that? Cool. Okay. So then we have integral e to the what? Negative what? Ah, good job. And instead of dx we have square root of b dw, like that? Is that correct? Nice. What happens to the limits of integration? They're the same thing, right? Yeah. Negative infinity to infinity. Now what?
Take out square root of b.
Yeah, take out the constant. Negative infinity to infinity, e to the negative w squared dw. Now what? Oh, did they give it to you?
Yeah.
Oh, look at that. It's equal to what? Pi. So it's going to be square root of b times the square root of pi. All done. Math. Fine. Okay, so what can we pull out to the front here? We have 1 over 4, right? And then you pull a 4 out, correct? And then you end up with cosine theta d theta over 1 minus sine squared theta, like this, like that.
Whoa, where did that,
What?
Okay, I'm caught up.
Okay, you caught up now? That was fantastic. Wait, what? I'm caught up. Okay, excellent. That was an excellent, excellent. I know.
You went from whatever form
I know,
to
I know.
form, and I'm like,
I know. It's like,
figure out where
bah!
it came from.
Where did it come from? Okay, 1 minus sine squared is cosine squared square root. So what does that turn into? Cosine theta. So what do you end up with? D theta? Like that? What are the limits of integration equal to? Do we have to do do we have to did you just say did we have to do we have to do that right now? Is that what you said? Nice.
Is sine ever equal to 4?
Well, hold on. Here's
From 0 to pi over 2.
0 to what?
Pi over 2.
Well, we could if we wanted to. Let's do this. We could change the limits of integration right now. Oh, we don't have to. We can go back, right? So if we integrate this, what does it equal? It just equals what?
Theta.
It just equals theta, right? You with me so far? So, but what does theta equal?
4 sine.
What does theta equal? Yes, everybody talk at once, slightly at a different place in the, it's sine inverse of what? X over 4, correct? Do you agree with that?
Yeah.
So we're now doing the integral 0 to 4. Sorry, no, I don't want to, that's not. So what are we doing here? We're doing sine inverse evaluated from what to what? 0 to 4. What's a problem with that?
You can't have, I don't know. You can't take sine inverse of 0?
Yes, you can.
No, okay.
Can you just plug things into that?
Yeah.
Oh, cool. Nice. Okay. Great. We solved it. Okay. That's nice.
That was
So,
so anticlimactic.
no, sorry. So it's sine inverse of 1 minus sine inverse of 0. It's fun. I always expect there to be some sort of sinkhole of, you know, can't plug in all of a sudden. Nice. What's sine inverse of 1? Pi over 2 minus what?
Pi 2.
What's sine inverse of 0? No, it's 0. So it's pi over 2.
Oh, we got it. We just did math.
One word. What's it asking you to do? Yeah, one word.
Plug in and prove.
One word. Integrate. Who, Matri, you said that? That was you?
Yeah.
Good job. It's asking you to integrate. That's what it's asking you to do.
Or you can differentiate.
You can do a lot of different things, yes, but in general, the method that we're going to use is start with the derivative in the differential and come back to what it wants you to show. So yes, you could differentiate the first one and try to get that. You want to integrate, right? So do you remember what you have to do first? I think you've done something like this before. There's a word for what you have to do, or a sentence for what you have to do first. If you're going to integrate this, what do you need to do first? Separate variables. If you don't separate variables, you get 0 out of like 9 points on the free response. You have to separate, so you have to separate. So if you separate this thing, what does that mean, separate variables? Does anybody remember what that means? Yeah, get the y's on one side with the what? the dy, right? And get everything else with the dt and t, but there's no t's in there, right? So what do we end up with? We end up with dy over y minus a is equal to k what? dt. Nice. So what do we do now? Did we separate? Yay, we separated. Fantastic. What do we do now? We integrate now. What does the left side become if we integrate this thing? Ln of y minus a equals, yeah, I put it on the right side. It's fine. Plus what? kt plus what? Plus c. At this point right here, it's in log form. So what do we want to do? Yeah, e to the kt. To do what?
Sometimes people write ln c.
Oh, they write ln c just to make it nice. Oh, that's fine. It's okay. Either way, it's fine. Equals this right here. Is that correct?
Yes.
Did I do that right?
Yes.
I think so, right? It's kind of nice. So what do we do now?
Look up there.
We look up there and we're like, huh, we're almost there. What do we do now? C e to the kt. Okay, that's nice. So what is e to the c? E to the c is just some c. Ready? So I'm going to do this. I'm going to write a different c. It's blue. I know. I understand what you want. Okay?
I actually don't like when people do that.
Okay, good. Okay, so you're like, I'm going to agree with you, but I'm just going to throw something out there. I know. So are we almost there? Seems like we're almost there. So there's that absolute value. What's the logic that gets us out of the absolute value lock? Yeah, what do we think? Is there anything that we need to put in there? Either way, you can just go to this, okay?
Because what that says right there is y minus a equals c to the c times e to the kt, or y minus a equals negative c times e to the kt. Either way, it's some c.
Some c. Either way, it's some c. Like you can make c anything you want, so we're good. Are you okay with this? This right here, the only reason I wanted to do this one is if you ever see a separation of variable differential equation on your BC exam, which is not guaranteed, but it's highly likely, you should be like, yes. Because do you know how many points this work is worth on the test?
No.
How many points do you think? No, it's not the entire free response. This would be part of a free response, right? Free response questions worth 9 points each. How many points do you think just this work is worth usually? It's like 5 points. It's like 5 freaking points. That's awesome. In my opinion, doing this type of work on the AP Calculus exam is the best return on investment you have on the entire exam. When you look at it, you think, yes, just get it done and get 9 out of 9 and crush it. Because it's like, literally, it's like 1 point for separation of variables, like 1 point for isolating, and then like writing a sentence at the end. It's super nice. Be good at it, but you have to separate first. Okay, let's talk about something that's a lot more curvy, shall we? What's this? What are these? Slope fields. Raise your hand if you kind of remember what a slope field is. What's a slope field? Tell me what it is in your own words, Izzy. Wiggles. I like that. Wiggles. We're gonna do math with one word. Wiggles. Yes.
It's like the coordinate plane.
Yep. Coordinate plane. Yep.
Where each point there's.
If I had an initial condition of, I don't know, let's say right here, what could it theoretically be doing? It could go whoop like this and maybe like that, right? Let's say I picked a different point. Let's say this one right here. Kind of looks like it might go down like this, right? And then went up maybe, and then down, something like that. Is there a different one here? How about this one? This one looks like it goes whoop, and this one goes whoop, something like that. The idea is, at any given initial condition, can you draw a specific function? Yes. So how many functions does a slope field represent? An infinite number. A slope field represents an infinite number. It represents the solution to a differential equation. Fantastic, because how many solutions does a differential equation have? An infinite number. When you integrate, things get bigger. Fantastic. Nice. So you will get, I mean, this is a super common question, on which one of the slope fields is the slope field below. Which one is it? So when you're doing slope field analysis to figure these things out, does anybody remember how you go about doing slope field analysis? There's lots of different things you can do. Literally plug in points. It's the best thing to do ever, right? You look for commonalities here. So for example, if it's x minus y, what does that mean about, what happens if x equals y? You have a 0 in the denominator. So what's going to happen when x equals y? What are you going to have? Some sort of, it's going to approach like a vertical tangent, right? X equals equals y. So one thing you can do is on each of these draw x equals y. Yay! Right? Here's x equals y on each of these, right? So is it going to be a? No.
Why is it a?
Well, let's look at a here. What does it look like?
Vertical, I was
What does it
thinking
look like the slope is at each of
Right.
when y equals a? It looks like it's 0, right?
Yeah.
So when x equals y, it's not going to be a, right?
Right.
So we can eliminate that one. What about for b? Does it look like they're going vertical?
Yes.
It does. What about this one? Does it look like they're going vertical?
A,
Not always, right? So which one do we think it is?
B.
Do we think it's b?
Yeah.
Sometimes it can be that easy. Sometimes it can be that easy. Other things you can do instead of doing a whole line, you can just do one specific point. Like you can look at these and go, where are they really different? So for example, at 0 right here, when x is equal to 0, it looks like the slope is 0, right? Whenever x is 0, the slope is 0. Is that going to be true here? No, it's not. When you plug in 0 here, it's going to be y over negative y. It's going to be a lot of different things depending on what y is. It's going to change with respect to y. Do analysis based on specific points and specific functions that are linear.
Wait, scroll down a little bit.
Mhm.
See?
Yeah.
That point, what looks like x equals 3.
I'm sorry.
Wouldn't 0 be like a horizontal axis point?
Potentially, yes. Potentially, yes. Correct. But it looks like it's going straight out and straight out. So then I can almost draw a straight line. It's fantastic. I'm really good at this game. So what about 1, 4? What do? You go to 1, 4, which is approximately, I don't know, like 1, 4, like right here. So what does it look like that one is?
Like
It goes like this, right?
yeah.
Little S curve. So can you draw lots of different solutions in here? Sure. There's different classifications. Like anything you do in between here and here is going to look pretty much the same on this one, it seems like, right? Anything above is going to come down. Right? Anybody know what type of curve this is? Logistic. Thank you. Logistic. What types of things do logistic curves model? What?